Hello, my name is Carlos Vincent Fernandez, and I will demonstrate the Module 2 examination called the Experiment 5, which is the non-inverting amplifier, which is the op-amp. So what is the op-amp? It is called the operational amplifier. It's a voltage amplifier that uses the external feedback components like resistors, capacitors, between output and input terminals. So it has a two-type called an inverting op-amp, operational amplifier, and non-inverting operational amplifier. So the inverting op-amp is connected to the negative terminal of the op-amp component, while the non-inverting, which is I will demonstrate here, is connected to positive terminal. So how? So I will build first the circuit before I show you. So R1 here, and then voltage V1, and then we have the R2, and then op amp. So in experiment in experiment 5, I will use the ED8040, which is a quad high-speed operational amplifier. Now here the next is the voltage here and voltage here, and then that's the one, then here, and then here. They connect here, negative, and then as you can see the voltage, okay, the V1 is the input voltage that connects to the positive terminal of the op amp. That's called the non-inverting. But what if in negative terminal the voltage input connects to the negative terminal? That's called the inverting op amp. Okay. Now next here, and then here, I'll put here, and then the by sign. So R1, the value of R1 is 10 kilo, sorry. And then the R2, 10 kilo, and then the V1 has a 1 volt, and then 5V. This is called the VEE1, and then the V3 VCC1, 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 and then 5 volts. And then now we completed the circuit, so I will now label. So out 1, this is the out 1, and this is the IN1 is the input. Okay, now we can now see the behavior of this non-inverting amplifier. So let's type DC. DC VIN1 -5 +5 +5, and then 1, then 1, then control M again. So that measure DC output, find V out, voltage output, when V IN1 equals to 1. So now let's put here, that's the answer. So now first, before we see the behavior, the R2 is called the feedback resistor. So this node here is the virtual earth node. So the resistors, which is the R2, RF, and then the R1 simple potential divider network across the non-inverting amplifier with voltage gain of the circuit being determined by the ratios of the R2 and then R1. So now first, the voltage gain of these amplifiers, non-inverting amplifier, is which is the I1 plus R2, which is the RF, the feedback resistor over R1. So this is the voltage gain of the non-inverting amplifier. So now, we can now see the behavior. So let's run, oops, the V1, input 1, oh wait, sorry. VN1. Wait here. I'm sorry for the count out. So I think I made a mistake here. Output 1 and let's run. So sorry for the count out again. So and then sorry, I forgot to rename this voltage input VN1. So now let's again run, and then let's see the traces to the voltage input 1. As you can see, it's linearly. So as you can see, -5, -4, and so forth and so forth. So as you can see, it's linear. So they are increasing in the x-axis and the y-axis. Now let's see the measured DC output. Okay, so when V equals to 1, voltage input equals to 1. So as you can see, it has a 1.98462 at output 1 with the input voltage is 1. So next one, let's have, how about, let's see if 2 volts. So let's rerun again. So it has a 3.98624 or 3.99 at 2 volts. Okay. Now next. So now next is 3 volts. Voltage equals to 3. So as you can see, it became 3.9. Wait, sorry, I forgot to run again. Yeah. So at 3 is 4.97762 or called 498. So let's see the 4. The positive 4 here. Okay. Oops, I forgot to run. So spice error log. So as you can see, it still at 4.97878 or 4.98. So next one is 5 volts. Run again. So it is still at 4.98270 at 5 volts. So which means that it reaches the maximum of the voltage output. Okay, so as you can see here that 5 volts and 5 volts. So which means that this 5 volts is reach its maximum. So how about if it is in minimum? So let's say 5 here and then 5 here, negative 5 here. So which means that this part is the minimum. So let's see if negative 5, so to see the minimum, so okay, so spice error log, and then we have a 4.98273. So it means that in positive side is 4.98, while in the negative side is 4.98. So which means that this is the minimum. And then the maximum is 4.98, positive 4.98. So now, let's see the voltage gain. So I will write here, let's say it's blue. So the 1 plus R2, that, which is the feedback, and R1 is the voltage gain of the circuit. So 1 plus R2 is 10K divided by 10K. So let's see, I will calculate 1 plus 10 times 10 kilo, 10 times 10 to kilo. So it is 2 volts of the voltage gain of this circuit. Now, of this non-amplifying circuit. So now, next one is to change the R2. So the R2, we can change the feedback resistor to 20k ohms. Okay, now let's see if I run again. So let's see if something was changed. It's still at negative 4.98. So therefore, there's no change even if we change the feedback resistor. So now, let's see again. Let's compute again for the voltage gain of the circuit. So 1 plus R2 feedback resistor is 20k divided by 10k. So it has a 1 plus 2. I will check it. 20k. Okay, 1 plus 2 equals to 3. So 20 divided by 10 is 2. So therefore, this circuit has 3 voltage gain. I mean, this circuit has a voltage gain of 3 volts. Okay, so now lastly I will put my name first for this circuit. So this is called non-inverting amplifier, and then my name. So that's all for this video demonstration for Module 2 examination. Thanks for watching.